Now, in this lesson, we're going to work with composite functions. Let's say that f of x is equal to 2x plus 5, and g of x is equal to x squared minus 1. We want to find f of g. Now, notice this is not multiplication. If you ever see a closed dot between functions, that means multiply. But here we're dealing with a composite function, which means one function goes inside another. So f of g means g is inside of f. In other words, this is f of g of x. To find f of g of x, we replace g inside of f. Since g of x is x squared minus 1, we replace every x in f with x squared minus 1. So this becomes 2 times x squared minus 1 plus 5. Now distribute the 2. That gives 2x squared minus 2, then add 5. So the final result is 2x squared plus 3. Now let's look at g of f. This time f is inside of g. So we replace x in g with the expression for f. Since f of x is 2x plus 5, we plug that entire expression into g. So instead of x squared minus 1, we have 2x plus 5 squared minus 1. Now rewrite the square as multiplication. That's 2x plus 5 times 2x plus 5. Let's multiply using FOIL. 2x times 2x gives 4x squared. 2x times 5 gives 10x. 5 times 2x gives another 10x. 5 times 5 gives 25. Now combine like terms. 10x plus 10x gives 20x. So we have 4x squared plus 20x plus 25. Now subtract 1. That leaves 4x squared plus 20x plus 24. Now let's evaluate a composite function using numbers. Let's say f of x is 4x minus 3 and g of x is x cubed plus 2. We want to evaluate f of g of 2. First find g of 2. Replace x with 2. 2 cubed is 8, plus 2 gives 10. So g of 2 is 10. Now find f of 10. Now replace 10 in the function f. F of 10 equals 4 times 10 minus 3, which gives 40 minus 3. So f of g of 2 equals 37. Now try this one. Evaluate g of f of negative 1. First, find f of negative 1. 4 times negative 1 minus 3, which gives negative 4 minus 3. F of negative 1 is negative 7. Now replace negative 7 in the function g. G of negative 7 equals negative 7 cubed plus 2, which gives negative 343 plus 2. G of negative 7 is negative 341, meaning g of f of negative 1 is negative 341. And that's how you evaluate composite functions step by step.